Very good morning to everyone. This is Dr. Mama Ghazal. Today we are going to talk about solid state chemistry. Solid state chemistry is basically a very integral part of a chemistry where we are talking about the changes, deformations, and formations which are taking place deep inside the solid material which we are having and the molecules which are comprising of that particular solid state. When we are talking about solid state chemistry, it is usually classified either crystalline or amorphous solids. And the term solid means like it's generally employed for substances which are crystalline in nature. And in these crystalline solids, the constituents may be atoms, ions, or molecules. The definite and ordered arrangement of the constituents extend over a large distance in the crystal, and it is called a long range order also. So when we are talking about crystalline solids such as sodium chloride, NaCl, ice or sugar, etc., possess a sharp melting point. And when on the other hand, because as I'm telling you that solid state chemistry, and it is broadly speaking, it has been divided into two parts. One is your crystalline solid, another is said to be the amorphous one. So amorphous solids are like, you can see an example of amorphous solids in a glass, pitch, rubber, plastics, etc., although possessing many characteristics of a crystalline solid such as definite shape, rigidity, hardness, but are devoid of a regular internal structures and melt gradually over a range of temperatures. For these reasons, like we are not able to consider as these amorphous solids as a true solids, but rather highly supercooled liquids in place of that. So when we are talking about this one, an amorphous solid exhibits the same value of any property in all the directions, and it is said to be the isotropic one. For example, when we are going to talk about the refractive index, thermal and electrical conductivities, coefficient of thermal expansion, solubility characteristics, which are independent of the direction along which they are measured. When we are talking on the other end about the crystalline solids, those are those belonging to the cubic classes, where you are able to see about the unit cells, the crystal lattice, crystal structure, all these things, and that is said to be on the other hand is said to be the anisotropic. In these cases, the magnitude of a property depends on the direction along with which it is measured. Isotropy arises due to the fact that amorphous solids have the same arrangement in all directions. So here, if you will see better, that solid state chemistry is most central part of a solid state science and is considered with the synthesis, structure, properties and applications of solid materials. Wherever we are having the solid state materials, and in that the structure, that synthesis, the properties and the characteristics we can easily analyze by using the this particular chemistry, which is said to be the solid state chemistry. Because of their high increasing demand and high increasing operations and applications in a field of metallurgy, ceramic technology, laser chemistry, manufacture of artificial gems, whatever the artificial jewelry which we are wearing and having. So in that, like diamonds and emerald, rubies, which are those said to be the gems, and those are also possessing the property of this solid state chemistry, whether it is a crystalline or a amorphous one, and that crystal lattice, proper geometrical arrangements, everything we can learn in a form of a solid state chemistry. Geochemical processes, chemistry of polymers and propellants have added new dimension to their importance. Why it is so much important to read about solid state chemistry. Solid electrolytes are also a class of materials which exhibit high ionic conductivity comparable to those of strong liquid electrolytes. Because when we are talking about solid, that solid has been divided into different parts, like whether it is a metal, semi-metal, or semiconductor or insulator. All these properties has been defined on the basis of its conductivity and resistivity. And those conductivity and resistivity has been defined on the basis of the energy band gap, by which we are having an idea like this particular solid lies under the condition or under the segment of your metals, semi-metals, semiconductors or insulators. Solid state ionic, that's why this is a reason that these things, this means in this proper time, this is having a very thrust area or demanding area because of the studies of the solid electrolytes, which we can easily do. And the most widely used method for the preparation of solid electrolyte is solid state reactions, which is the direct reaction in the solid state of a mixture of solid starting materials as well. So when we are talking about solid state reactions where there is a particular reactants which are working there, but it will be means little bit different from chemical kinetics, because in chemical kinetics, if we are saying and having that A plus B, which is giving you another kind of a product which is said to be P. In that, it will be like when we are talking about this one. So, in solid state reactions, the reactants have only restricted access to each other as compared to the reactions in the liquids or of fluids, where intimate contact between reactant molecules is a natural consequence of the kinetic nature of those particular reactants. And in solid state reactions, what is the difference in comparison of the fluid reactions or the liquid state reactions? At least one reactant must diffused into the other in order that the reaction may start initiating, executing, and propagating. Therefore, the main point on which the chemical reaction in solid differentiate or distinguish themselves from those of occurring in a liquid or a gaseous states are the effect of its lattice structure and diffusion mechanism. That it's that the solid state reactions are basically based on the diffusion mechanism and the effect of the lattice structure, whether it is a vacancy, it is a kind of any kind of a defect or a impurity or any other material which is going to be added on that. Solid state reactions basically divided into two stages. In the first stage, you can see that the first stage reaction will give you an idea about the formation of your nuclei of the product, and the second stage will give you an idea about the enhancement or the growth of the product layer. Usually, when we are talking about solid state reactions, they are said to be the diffusion controlled. Tarnishing, decomposition, polymer degradation, polymerization, and oxidation reactions involving solid. So these are the basic things which we have to consider when we are going to talk or taking under consideration a solid material and going to be in a progress of a solid state reaction. Here we are going to talk about how it is important and how much it is important to talk about the solid state reactions. Solid state reactions are said to be the diffusion control process reaction, and which is another term is said to be the migration of ions, the same migration of ions which we are seeing in a electrochemistry or electronic state reactions which are there. Solid state reactions mixing does not occur at the molecular level, because when we are talking about solid state reactions, the atoms and ions which are displacing their places, and after that we are talking about that to fill that vacancy either with the cations or the anions. So in that way, solid state reaction mixing does not occur on the molecular level. We are talking about the ionic conductivity here basically. In all types of solid state reactions, at least one of the reactant must diffuse towards the other reactant. And the solid state reactions generally depend on the biography of the solid or the origin of or the base of a solid which we are using under consideration to learn about the study of that particular solid material, which is exclusively the method of the preparation, storage condition, and as well as the primary treatment. So in that way, this is the important points which we have to consider when we are talking about solid state reactions. Now, the classification of the solid state reactions. Solid state reactions has been classified in different and various parts. One is said to be the decomposition reaction, where you are seeing the things like that. It is possible when a solid is heated below its melting point, then you are means that solid is splitting into two different products, which you can see that calcium carbonate, which is calcium oxide, and carbon dioxide it is given. In additional reaction, you can see that A is going to be accumulated with B and it is forming another product which is said to be AB. In the same way, when we are talking about magnesium oxide and aluminum trioxide, which is combining with each other, an addition reaction of a solid state material is going to be takes place. When we are talking in terms of exchange reactions, so exchange reactions are generally possible in following three types. One is said to be A plus B and BC. So A is going to accumulate it with the C and B is going to be individual or a isolated one. This is one example of exchange reaction. This is said to be one possibility of that exchange reaction which can take place. Another is that magnesium and zinc sulfide is going to accumulate it with each other or exchanging, and magnesium sulfide and zinc has been formed in that way. So this is a one kind of a probability or a possibility for an exchange reaction. Another is that if two reactants which are together and two reactants again here together and they are accumulating and exchanging their positions, then the first reactant is going to be mingled with the fourth one and the second will be going to mingle with the third one. So in that way, we are feeling and having an idea about the exchange reactions which are going to take place in solid state reactions. This type of reactions are also very much common in a solid state reaction. Why? Because the reactants are generally solid and this type of reaction need more temperature which is required to exchange and to form all these products in the proper synchronized way. We need the temperature which will be more than 1000 degrees centigrade. The fourth one is a gas solid reaction where you are seeing the tarnishing reactions. Tarnishing reactions where you are losing some luster and losing some effect of that, and again they are mingled with another one and forming a layer which is said to be in that way. And tarnishing reactions are very common example of a gas solid reactions which is used to process in which a solid reaction with the gas accumulated and to form a solid compound and which build up a thick layer of the product between the two reactants. So in that way, we are having this solid state reactions. Some example of gas solid state reactions are oxidation of metal, which are a very common example, these types of reactions, and generally depend on the compactness of the product layer, which is formed in between the reactant. This type of reaction is a very good example of diffusion control process. Oxidation of metal, like you can see in that oxidized jewelry which is there, in that you can easily see that this gas solid reactions which are there, black jewelry or oxidized jewelry, which are a common example of these oxidation of metals and which are coming under the category of gas solid reactions. When we are talking about the last reaction, which is the classification of that solid state reactions, that is said to be solid liquid reactions, where that cement is a solid and any moisture which we are considering as a water, and then it is amalgamating with each other or accumulating with each other, and it is giving you another product which is said to be the solid. So that corrosion of anodic dissociation and electro decomposition of metals are common example of this type of a solid liquid reactions. Hydration of a cement is also an example of this class of reactions which are taking under consideration when we are talking about this all solid state reactions. So for today, I'm going to conclude today, and bye for now. We'll meet in another video. Please like, share, and subscribe my channel.